Hey developer, welcome to a new video of Future is Data series. Today in this video we will be talking about how indexing works in databases. So let's start with the video. First, let's take an example. Let's say you have your data structure and algorithm book. Now you want to read something related to the graph. Then how you will go in graph chapter? There are two approaches. The first approach is linearly you will check all the page one by one. Let's say from page 1, page 2, page 3. In this way you will check all the pages that where your graph chapter is there in your book. And the next approach is from the first content page you will check what is the page number where graph chapter is starting, and then directly you can go to that page, right? So these are the two possible way by which you can go in graph chapter of your book. Now think which is the most effective one. Definitely the second one, because in the first one linearly you are checking all the page from one to the end of the book to find this graph chapter, and in second approach you are directly going in that particular chapter only. Here what you are doing, you are checking the index page or the content page of your book, that is one page, and then directly jumping to that particular page where graph is starting. So definitely this second approach is the optimized one. Now if I want to read some subtopic of graph, then what will do? The first thing is again from the index page I will take the page number, I will go in graph chapter. Inside that graph chapter I will read all the page, check that whether my topic is present or not. And the second thing that can again happen, that in the index page only you are listing all the subtopic with their page number. That graph chapter is starting from page 120 and the first topic of graph chapter is, let's say, 121, then 122. In this way what can we do? We can just keep all the information about the subtopic in the content page also. So that will be more helpful. Like if you have any specific topic that I want to read this thing of graph, then from index page only you will be able to go there. So what will be the problem here? The problem here is the size of your index page. If you want to keep this subtopic information in the content page or the index page also, then the index page size will be huge. Let's say in database you want to run a select query. If you don't have anything, then it will check all the rows of your database. So this is linear time complexity which will be taking big of n time. But if you have any index on that column where you are putting your filter, then it will first check that what is the position of that row where the condition is matching from the index that you already have created for the data. Internally, database store the data in block format. You can think of a block as a small unit of space in your hard disk of your laptop. So a database is a collection of blocks. There will be a lot of blocks. Now inside one block there can be multiple rows of your table. In the next block there can be multiple rows. In the next block there will be multiple rows. And these blocks are connected with each other with a pointer. Think of a linked list where the first block, let's say in first block you are storing 5 rows. And then first block have the address or the pointer of the second block. From there you can go to the second block, and in second block there will be some rows of the table. Let's say here the number of rows is, instead of 5 it is 6. Then again it will have pointer. From that pointer you will be able to go in the third block. So in this way internally database store the data. Now you may ask that why inside a block there is 5 rows and inside another block there is 6 rows. Okay, the answer is the size of the row. If the size of the row is big, then definitely in one particular unit of space there will be less number of rows. And if one row is having small size, then definitely in that block there can be some more number of rows as compared to other blocks. Now you may ask that when I am looking for the graph chapter, then whenever I will be getting a page starting with graph chapter, I can stop iterating, I can stop searching, right? So then all the time complexity to find the graph chapter in your book will not be n, it will be lesser than n. But guess what? When in database you will be searching from some where condition, let's say select start from student where department is computer science. So when you are running this query, for the first time it will get the row. It will never stop there, because it can happen that your database containing a lot of students where the department name is computer science. So definitely here you need to search all the rows, not like once I found a row there I will stop looking for. So here you need to search from 1 to n all the pages, all the rows you need to search. Without index we will be able to search very fast when the number of rows in your table is less. But when your table is containing millions or billions number of records, at that time to have a good select query you need a good index definitely. Now take the mathematical example that how index is working. Let's take that every row is constantly taking 10 bytes in your memory. Now one block has 50 bytes. So definitely each block will store 50 by 10, which is 5 number of rows. Now let's say in a table we have 100 number of rows. So how many blocks will be needed? It will be 100 by 5. That means we are using 20 blocks to store that table into the DB. Now if I want to search anything among these 100 rows, then definitely the time complexity will be big of 100, because it will be searching all the values starting from 0 to 100. But when you will create an index of a particular column of your 100 rows database, then you have 20 blocks. That means the index size it will take is 20, because it will keep a hash map that this block is storing this information, this block is storing this information in this way. So approximately it will take 20 space. So when you will be searching some of the row with some where condition, then definitely first it will check in the index page which is of size 20 that what is the pointer or what is the address of the row what I am trying to find. Then it will find that, or maybe in that block it will linearly iterate that which row is matching your where condition. So what is the total time complexity? In binary search you will be looking for that address, so which will be taking log of n. Here the size of the index is 20, so it will be log 2 base 20, and then linearly you will check all the pages of that block what your condition is matching, and one block is containing 5 rows. That means it will take log 2 base 20 for fetching the address, and then another 5 for fetching the row. So in total it is way lesser than n time complexity. Now let's discuss what are the drawbacks of using index. Yes, index is not only always positive point, over index can again be a negative point. The first drawback is memory. Here in the above example, if I want to create an index in our that 100 column database, it is taking extra 20 block of space, right? If I want to create 2 index, then it will again take extra 20. So in this way, whenever I will be creating some more indexes, then it will take some more spaces in your database. And at a point, it can happen that your table size is much more smaller than your index size. Index is taking a huge space as compared to your table. So it's one of the major drawbacks of creating more indexes in your table. It is taking huge extra space. And the next drawback is insert and update problem. Index definitely make reading faster, but when you already have an index in the table, that means when I am trying to insert anything in the table or I am trying to update anything in the table, it will do 2 operations. One is storing the data into the row, and the next is updating your index. So if you have one index, then 2 operations is happening. One is storing and another is updating the index. If I have 2 index, then I will do 3 operations in each insert and update query. One is for updating the row and 2 is for updating both the index. So in this way, every time you will be adding indexes, every time the number of operations in insert and update query will be increasing. So index is making your database slower when you are inserting or updating any rows. So now come in the conclusion. So the question is again same, will I create index or not? Yes, definitely we can create index, but it need to be as per our requirement. If we have a very read heavy system that user is always reading the data, at that time we can compromise on insert and update because we need to make our read faster. So at that time we can create some more indexes like yes, read will be faster, user will be happy. We can compromise on insert and update. But if you have a write heavy system where you will be inserting and updating frequently, at that time you will avoid creating multiple index in the table because it can make your inserting or update query very much slower, increasing the number of operations. So that is a topic of system design, that on which column you will be creating indexes and on which column it is not required to create. To sum it up, indexing is like having a super fast map for your database. It helps you find what you need quickly and saves you a lot of time. By using index smartly, you can make your database work better for you. Use index wisely because too much can slow things down. So keep indexing and make your database slow.